Okay, students, so welcome to the second part of the lesson. So we're working with angles, beginning of trigonometry, and now we're going to move on to what we call radian measure, which may be new to you. Okay, so the idea is you're used to having 360 degrees in a circle, but it turns out really humans just made that up. We could have made anything we wanted to, like we could have 500 degrees in a circle. I think it's said that the 360 came from, the cycle of a year, and instead of using 365, use 360 because that's a little bit simpler number. That's what I've always heard anyway. So anyway, what a radian measure is actually a real number measure. It's more like a discovery based on things that we know about a circle, and it turns out that it has a lot to do with the number pi. So the first thing I want to show you is what the definition is, and the definition of a radian is we say the radian measure of an angle is the directed length of the intercepted arc on the circle. And a couple of things are a unit circle just means you have a radius of 1. So it's easy to represent this by a diagram, and the idea with this is you have a radius of a circle, and then you have the length of this arc. So these two things right here, if they're the same, then that's defined to be 1 radian of measure. So that's kind of the idea that's generated by that then. And then with a little simple mathematics, we can actually derive what 1 radian is. So it's just basically you got a radius and this arc, if they're exactly the same, then that gives 1 radian of a circle. And what would happen is if the arc was twice as big as the radius, it would be 2 radians, and so forth. Okay, so to further demonstrate this, I'm going to open up this applet, and it's a really good way to show students visually what we mean by a radian measure here. Okay, so as soon as this thing loads up, I'll take you through that. Okay, so here's what you have. And this is a really good thing to show students, I think. So basically you have a radius of 1. I can change that radius. And I'm going to change this angle. So the idea is 1 radian is right here. It's hard to get that thing to stop on the right thing there. Okay, so basically the arc length are the same. That's 1 radian. Now if I continue to do this, okay, now I'm going to get 2 radians. Now the length of this arc is 2 times the radius. And then if I go 3 times, I'm almost halfway around the circle when I do that. So that would be 3 radians when you do that then. Now 3 radians is a real number, and it's real close to a famous number. Do you know what that famous number is? Yeah, it's pi. Pi is 3.14. So the idea is there's going to be a kind of a unique connection between pi and one of the angles. So you can continue to go through this, and that when you get there's 5 radians, and then if you get to 6 radians, then you're almost an entire lap around the circle. So that's it. So hopefully that visual will help you make sense of what we're talking about with radian measure then. Okay, so here's kind of the idea then is from geometry, we have this thing that you may have seen in a high school geometry class. So the idea is if you have an angle, this degree measure is the same as the degree measure of the arc. So in other words, if you had a circle like this, and if this was 60 degrees, well then this arc is also 60 degrees. Okay, that's how we defined the degree measure of an arc of a circle. Okay. So that we're going to use that important fact here in just a minute. So the other thing is, let's just kind of look at this. Here's 1 radian. Can you tell me approximately how many degrees you think that is? Okay, 60 degrees. Okay, let's see, 60 degrees. It isn't 60 degrees, but it's around that. I'll show you what that is in a minute. Okay, do you know what the the circumference of a circle is? That formula is circumference is 2 pi r, 2 pi times the radius. Okay, so here's what you have. In a unit circle, the circumference is 2 pi r. However, radius is 1, so we would get the circumference is 2 pi. Okay, so we get that. So we end up getting this then. So what this says is all the way around the circle is 2 pi. All right, so at 2 pi radians would be the circumference, then that would be the same as 360 degrees based on this diagram right here. So again, what I'm saying by that is if you go all the way around a circle, we know that's 360 degrees, but all the way around that circle is 2 pi. That's the circumference of that circle, so they have to be the same. So we get this real important fundamental property that 2 pi radians is 360 degrees, okay? And then this is an equation. So we have the equation 2 pi radians equals 360, and then if we were to divide both sides of that equation by 2, we would get pi radians is equal to 180 degrees. Okay, so these are two things that you must remember is halfway around the circle is pi radians, all the way around the circle is 2 pi radians, and so forth. Okay, so if I was to go back to this applet, I'm going to show you one more thing on this applet because this is kind of a nice thing to be able to visualize well, so like I showed you. So the idea going back to this is if we get to 3 radians, so right now I'm at 3 radians, okay, you can see that I'm almost at 180 degrees. So pi radians, if I go all the way to 180 degrees, then I'm 3.14 radians, or pi. Okay, if I go all the way around the circle, like this, okay, then I'm at 2 pi radians. And notice that 6 radians is almost 360, okay? So if pi is 3.14, 2 pi is about 6.28. So think about that a little bit, and that kind of helps give you an idea of what we mean by radian measure then. Okay, so moving on to the next page, we're going to do this now. So we have this distinction. So this is an equation. So I'm going to have you do this. So what we're going to do is we're going to divide both sides of this equation by pi. And what we end up getting, this becomes 1, so we get what 1 radian is. Okay, now I'm going to take my calculator, and I'm going to do this now. Okay, so if I go through and do this, if I just take 180 divided by pi, use my pi key on my calculator, then I get that that's about 57.3 degrees approximately. So 1 radian is about 57.3 degrees. So if you were to go to the diagram, okay, in the previous page, I asked you what you thought a radian was, and 60 degrees was a good estimate. Well, actually, 1 radian is a little closer, is more like 57.3 degrees. Okay, so that's what that is. You don't really have to know that, though. Okay, so what we're going to do is we're going to do some conversions. And what you do is you convert radians, degrees to radians, you multiply by pi over 180. So I want to show you why that is. So the idea is really this. If you go back to this equation, pi radians is equal to 180 degrees. Okay, well, if we want to divide both sides of this equation by 180, then here's what we'll get. We'll end up getting 1 degree is equal to pi over 180 radians. Okay, so every time a degree goes by, you actually have pi over 180 radians. So if you had 2 degrees, it would be 2 pi over 180. If you had 10 degrees, it would be 10 pi over 180 and so forth. So that's why you multiply by pi over 180, okay? So the first thing that you want to know to do with this is to do conversions, which is real important. So if we have 60 degrees, we're just going to multiply that by pi over 180, and then you're going to reduce the fraction. Okay, so you got to know how to reduce your fractions well, and I'll show you how to do that on a calculator also. Well, you can divide both the numerator and denominator by 60. That's the biggest number. And if you do that, you would get 60 divided by 60 is just 1 pi, and 180 divided by 60 is 3. So pi over 3 radians would be the same as 60 degrees. That's in a reduced form. Okay, the next one, same thing. You just take negative 450 degrees. You multiply it by pi over 180. Okay, you go straight across, you multiply fractions straight across, so negative 450 pi over 180 is what you'd have. All right, one thing you can do on this is if your numbers end in 0, you can just cross that out because you're dividing by 10. And then we do this, okay? And actually on this one, what will happen is they both divide by 18, or yeah, by 18. So if you divide by 18, then you end up just getting negative 3 pi, okay? So that would be the solution of the problem. So that's how you do conversions. It's real simple. You just multiply by pi over 180 and reduce, okay? All right. So just to make sure you're on the right track with this, let's do the next two problems, if you will. So I would go ahead and pause my instructional video right now. Okay, so let's run through this and let's see what you did here. So this one, you just do 720 times pi over 180. And that's 720 pi over 180. Now, one thing you can do, just take your calculator, and what you'll find on this, if you can't do this in your head, 720 divided by 180 is just going to give you 4. So this would be 4 pi. Now, I gave this problem on purpose because what I was hoping you would see is if 360 degrees, hold on, that's 4 pi, sorry, so you've got the pi in there. So if 360 degrees is 2 pi, hopefully it makes sense that twice around the circle is 4 pi and so forth, all right? Okay, next one you should have done negative 36 times pi over 180. And let's see, the biggest number that I think these divide by is 9. Okay, so if I do 36 divided by 9 would be negative 4 pi. 180 divided by 9 is 20. So actually, I think both of them divide by 36 now that I think of it. So I'm going to divide both by 4 now. And then that will end up giving me just negative pi over 5. All right, so those are the two answers you should have got on those problems, is 4 pi and negative pi over 5. I want to show you kind of a shortcut that's nice to know on your graphing calculator. So if you put in 36 divided by 180 on this last problem, it's a decimal on that. But what you can do on this is you can convert this to a fraction. So the way you do this is you press your math button, and then option 1 is fraction. So you just press enter again, and see that's 1/5. So what we really found is that this is equal to negative 1/5 of pi. One more time I'll do that. This is real useful if you have real big numbers. So if you had something like 45 over 1,080, for instance, and needed to reduce that fraction, you just go math, fraction, and that gives you 1 over 24. Okay, so it's really comes in handy a lot. Okay, so let's move on, and I'm going to do the same thing, except now I've got some decimals, but we're still going to do the same thing, but we're going to use our calculator. So I'm just going to take 180.9, and then I'm going to multiply that by pi over 180. Okay, and I'll just strictly use my calculator on this, and then I'll round it off to 3 decimals. So I just take 180.9 times pi. Use your pi key too. Don't use 3.14. And divide by 180. That just gives you a little greater accuracy. Okay, and then we'll round that off to 3.157 radians. Okay, now I gave you this on purpose. Okay, again, 180 is pi radians. Well, I hope this makes sense because pi is about 3.14. This angle's a smidgen bigger than 180, so that's a little bit bigger than 3.14. Does that make sense? Okay, all right. Same thing on this. We do this. Going to multiply this by pi over 180, and just do that on the calculator. There we go. All right, and we just round this off to 3 decimals. So this is negative 5.502 radians is what you would have. Okay, any problem? Fantastic. Okay, let's go ahead and let you pause these two and go ahead and work these out. You'll need your calculator to do this, and unpause it or resume whenever you are ready to check your answers. Okay, so this is what I got. You can see my calculation. When I was rounding the answer number 1, I thought some students might need a little help on that. But I just put this in my calculator like I showed you. Now, if you look at the result of this number 1, when I did 90.5 times pi over 180, I had 1.5795222973. So what I'm going to do is, to go to 3 decimals, I just chop it off there. Now, since this is a 5, then this rounds up. And if that rounds up from 9, the only place it can go is 0, so that has to go up to 8. So you have 1.580. Now, if you write your answer as 1.58, that's also okay. You don't have to put the 0 on there in that case. All right, okay. All right, very good. All right, so let's see. Let's go ahead and move to the next thing, which we're just doing this in the opposite direction. So now the question is, we want to go from radians to degrees. There's 2 ways to do this. You can, if you have pi in your expression like you do here, you just replace pi with 180 and simplify and you're done. Or you can multiply both sides by 180 over, or not both sides, just multiply the expression by 180 over pi. The reason that you do this is because of this. Again, the one thing that you're not allowed to forget in this class is 180 degrees is pi radians. You've got to know that. Okay, if you remember that, then you can figure everything out, see. So what I'm going to do on this is I'm going to divide both sides of this equation by pi. And when I do that, that divides out, given 1 radian is equal to 180 over pi. So every time you have a radian, you have 180 over pi. All right, so that's the idea. Okay, so let's go down and do some examples on this, and this is pretty simple. It's mostly arithmetic. So pi over 6, well, the first method is just change the pi to 180 degrees and then divide. So 180 divided by 6 is going to be 30 degrees. Okay, so that's the first way to do that. The second way is take the pi over 6 and then multiply that by 180 over pi, and notice you're going to get the same answer. The pi's divide out, so therefore you're left with 180 over 6, divide, that's 30 degrees. Okay, you can do it either way. What I usually do is, if there's a pi, I just replace pi with 180. Otherwise, I do it the other way. Okay, so this one, excuse me, we're going to just do negative 7 pi over 8. Change the pi to 180, and then you're getting into some pretty big numbers on this one, so I'd suggest you just use your calculator. So I'm going to go negative 7 times 180, and then divide that by 8. I think I'll have decimals on this, so I'll just use negative 157.5 degrees. Okay, and the second method, what you're going to find on this second method, it just cancels out the pi. So multiply by 180 over pi. Pi's cancel out. Well, you can see you're going to do the same thing. Negative 7 times 180 over 8. It's going to give you that answer. Okay. Okay, and the next one, you can only do this one way. It doesn't have a pi in it. So this one, we're going to use the calculator. And we're just going to multiply by 180 over pi. And then we'll round that off. That's what we'll have to do. So I'm going to do 3.598. times 180, and then divide by pi, and then I'll round that off. So that's about 206, I'll just round to 2 decimals, 206.15 degrees. Okay, any questions about what I've done there then? Okay. All right, so let's see. Let's go to the next thing here. I'm not going to have you do any problems on this. It's pretty easy to do. Just follow the directions on that. You won't have any trouble with that, I don't think. All right, next thing I want to talk about is quadrants. And when we're dealing with quadrants, quadrants turn out to be a real big deal in trigonometry. It turns out that it's real important where your angle is, what quadrant it lies in. Might know this from college algebra or pre-calc or something. So you have quadrant 1, 2, 3, and 4. We usually use Roman numerals. And we do that counterclockwise, the way we would measure a positive angle. A couple of things that I wanted to mention that are kind of nice to know is these equivalents here. So this just says 2 pi is 360. Also 0 radians is equal to 360. It's kind of nice to know these, and you'll get this down over time. Also, pi over 2 radians is equal to 90 degrees. And then we already know pi is equal to 180. And then also 3 pi over 2 radians is equal to 270. You'll get that memorized because later in the class you're going to have that down. But it's kind of nice now to start making those connections. Okay, so what I'm going to do down here in this example is just, this kind of connects with some things we learned a little earlier. So what we're going to do is take this given radian measure, we're going to draw the angle in standard position, determine what quadrant it's in, and then we're going to find coterminal angles, but I want those coterminal angles to be in radians, okay? All right, so here's what I would do. I would just change this to degrees. I think it's just as easy to do this, so I'm going to use my calculator and find what that degree measure is. So I'll go 4 times 180, and then divide by 5, and that's 144 degrees. Well, we already learned how to do that, so let's just sketch a graph. Now that we know what the degree is, it's just as easy to do it that way. So just to review, if you're in standard position, you want to have the x-axis, positive x-axis. It's a positive angle. This is positive number, so you're going to go counterclockwise. So you would just estimate kind of where 144 is. So it's in that region there. Okay, and remember the quadrants go 1, 2, 3, 4. So this one is going to be located. It terminates in quadrant 2. Okay, so to me it's just as easy if you're sketching an angle in radians to just change it to degrees and do it that way. Okay, now we're going to find some coterminal angles. Well, back when we learned about coterminal angles, if you had 144 degrees, I taught you to just add 360, and then you would get a positive coterminal angle. If you subtracted 360, you would just get a negative angle. Well, I'm not going to do it that way. I mean, since I want this answer to be in radians, what we're going to do to find the positive coterminal angle, we're not going to add 360, we're going to add 2 pi. How come? Because 2 pi is equal to 360. So we're just going to do it that way. Now what I'm going to do is I'm going to put that over 1, and I'm going to get a common denominator. So the common denominator is 5, so I just multiply by 5 over 5. And then what I'll end up getting is I'll get 4 pi over 5. This becomes 10 pi over 5. Therefore, that's 14 pi over 5. Okay, now the other way you could have done this is you could have done this. You could have, to me, it's more time consuming to do it this way. You have 144 plus 360, and then that would give you 504. But then you'd have to turn around and do 504 pi over 180. Okay, well, you could reduce your fraction, like I showed you. If you do 5 over 4 divided by 180, get a decimal, and then you can go math, fraction, and 14 over 5. Okay, I wouldn't waste my time doing it that way. I'd just add 2 pi or subtract 2 pi is what we're going to do now. Okay? All right, so we're going to find a negative coterminal angle. So start with what I gave you. Now we're just going to subtract 2 pi. Okay, so what I'll do is I'll put this over 1. The common denominator again is 5, so I multiply by 5 over 5. That will give me 4 pi over 5 minus 10 pi over 5. So that's equal to negative 14 pi over 5. Okay, like that. So the answer to that is going to give, well, hold on, teacher. Sometimes the teacher does stupid things. So that's going to be negative 6 pi over 5. The way I caught my mistake is I thought about my answer. I'm real used to always when I get an answer, I think about it, and I didn't make any sense that it would be the same as this, but only negative. Okay, and you know, we all make mistakes. I do all the time. Okay, so that would be the result of that problem. Okay, any problems with that? All right, so let's see. I think I'm just going to do one more problem, and then I'm going to have you just do one like that, and then we'll kind of get to the remaining part of the section. So what I'm going to do on this one, I'm just going to do a negative angle, just kind of for a quick review. I'm going to replace the pi with 180 degrees, so I'm just going to convert it to degrees. Okay, so I'll just put in 12 times 180, and then divide that by 7. All right, and I get that. Okay, and it's okay if it's got a decimal, it doesn't matter. So that's approximately, and it's a negative angle, so it's negative 308.6, approximately. Okay, well, we're only sketching the angle, so it doesn't matter. That decimal doesn't really make any difference. Okay, so again, when we sketch this out, we always highlight the positive x-axis. Now, since it's a negative angle, which way do we go? We go clockwise, okay? And we just count it out. So this would be negative 90, negative 180, negative 270, and about around 38 more. So somewhere kind of roughly in there would be where that is. And then don't forget, you need to always show that arrow that shows the direction you're in. All right, what quadrant is that? Yeah, that would be quadrant 1. So we end up back in quadrant 1. So that would be the solution on that. Okay. Now if we want to do angles that are coterminal, I'm going to show you what I did before. Okay, if we want to find a positive angle, what do we add to it? We add 2 pi. Why 2 pi? Because 2 pi is 1 rotation around the circle in radians. Okay, well, we got to get a common denominator. That common denominator is 7. Okay, so we end up getting negative 12 pi over 7 plus 14 pi over 7. Okay, so we have 7, add the numerator, that's 2 pi over 7. Okay, so I would just leave it in radians and do it that way. It's faster that way. Okay, and then a negative coterminal angle. What are we going to do? Yeah, you're going to subtract 2 pi. You're going to subtract 2 pi. That'll give you another negative number, so you do that. All right, so get a common denominator. That's going to give negative 12 pi over 7 minus 14 pi over 7. That's adding 2 negatives, so that is negative 26 pi over 7. Okay, so that would be the idea on that. So just understand that 2 pi is 1 rotation around the circle in radians, and you got it. Okay, so what I'll do next is I'll have you go ahead and go down to this example and let you do that problem. And just one problem should be enough, so go ahead and let's do that. So you want to pause this and then come back. All right, so let's go ahead and you can check your answers and see if you did what I did. I'll just kind of talk through them real quick. So first thing I did is I changed it to degrees, replaced pi with 180. And 225 would be a positive angle, so it would go counterclockwise. You would be dead center in quadrant 3 if you did that. Okay, and again, positive coterminal angle, I add 2 pi. Negative coterminal angle, I subtract 2 pi. Okay? Right, so if you need to pause and just kind of get that down, and if you made any mistakes, get yourself corrected. So that'll show you how you should have done those problems then. Okay, so I'm going to move on to the next page. And what we'll do on this is we're going to finish up the section by learning a couple of important formulas that require knowledge of radian measure. So what we have here is we're going to look at the length of a subtended arc of a circle. So it turns out in any circle, if you know the radius, which is from the center to a point on the circle, and you know what we call the central angle, this is called the central angle because this is the center of the circle. If you know these two things, if you know that and that, then you can find the length of this arc. Okay, so we use S because it stands for subtended. Subtended means this little piece of the circle, so it's that little arc like that. So it turns out that you can find that just by knowing those two things. Well, let me show you how you derive the formula. You're doing what we call a part-to-whole proportion. Okay, we're going to compare the part to the whole. The part is going to be the arc length, just being this little piece right here. That's the part. The whole would be all the way around the circle. And all the way around the circle we call circumference. So a circumference of a circle is an arc of a circle, but it's the whole arc. So that's what that is. So it's part to whole. And then the angle in radians is going to be theta compared to 2 pi. Why 2 pi? Because 2 pi is the whole part around the circle. And we know all the way around the circle, we know all the way around the circle is 360 or 2 pi radians. Okay, so we're going to fill this in and do this, and I'll show you where the formula is. Okay, so arc length, you're going to replace that with S. Circumference, we have a formula for the circumference of a circle, which is 2 pi r. Okay, we did that a little earlier in the section, so we'll do that. And then over here, the angle in radians is theta. Theta is the angle that we're using there. And all the way around the circle is 2 pi. So if we have an equation, a part-to-whole ratio, so I'm going to cross-multiply this. Okay, cross-multiply is something you can do on a ratio. So I just go S times 2 pi equals 2 pi r times theta. So I'm just kind of crisscrossing that. I'm going this way, then I'm going that way. All right. So what happens is I get this. So now this is an equation. Now we want to find what S is. That means we want to get rid of 2 pi. So how do you get rid of 2 pi in this equation? You divide by 2 pi, right? Okay, so we do that. And then we'll have S equals, that cancels out, we get r theta. Okay, that's the formula. See, it's real easy. This is how mathematicians figure this stuff out. They use things we already know, and we keep finding more and more stuff here. So the formula is going to be S equals r theta, and that's what we're going to use. Now, the key thing on here is the measure of the central angle must be in radians. This formula does not work if this is in degrees. It'll give you numbers that are just nonsense. I mean, you'll get ridiculous answers if you forget to convert that angle to radians. All right, so let's work with this a little bit. So here's a couple of examples I want to look at. Okay, so we have this. We have a central angle. We have theta is 45 degrees. We have the radius is 12 units. Okay, I didn't really give you any units. We have that. And what we're going to do is we're going to find S. Okay, and S is going to be this part right here. So what we're looking at is the length of that arc right there. Okay. Also in geometry, an arc, like if it's AB, you write it that way. But S is what we use for that. Now I want to show you something on this. I'm doing this wrong on purpose because I see students do this all the time. So we know the formula is S equals r theta. Well, let's do 12 times 45. Let's just do that on the calculator and see what the heck we get here. Okay, so I get 540. Okay, now let me ask you. Okay, this is 12. This is 540. Don't you think that's a smidgen too big? Yeah, that's way too big. That's ridiculous. If I was looking at this, S looks almost like it's the same as 12. I would predict that the answer to this problem would be just a little bit less than 12, maybe around 10 or something like that. Let's find out. So you don't do it that way. That's totally wrong. So the first thing that you must do in this problem is you must convert the 45 degrees to radians. So what we learned a little while ago is the way you convert degrees to radians is you multiply by 4 pi over 180. Okay, what did I just say? Did I say 4 pi? No, you multiply by pi over 180. I wrote it wrong, but I may have said that wrong. Okay, so we do that. Now, you could reduce the fraction on the calculator if you wanted to. So we go 45 over 180. That's 0.25. I hope you know that that's a fourth. So that actually just gives you pi over 4. Okay, that fraction reduces down like that. Okay, now let's get this answer correct now. So we're going to do S equals r theta. So the radius is 12. That's given as 12. The angle is pi over 4. Okay, so that would give us 12 pi over 4. So that is 3 pi. Okay, like that. All right, now if I go through and do this now, so I'm just going to do this on the calculator. I'm going to do 3 pi, and I'm just going to get a decimal on this, so that's about let's just round to 9.4. So the answer to the problem would be 9.4 units. Okay, so a minute ago, see, I said 10. Okay, I had a ballpark figure there, right? So it goes like that then. And you want to use decimals on this because if you're actually given a measure of something, you want to use decimals. You don't want to go to Home Depot and say, hey, I need 3 pi inches of wood. Okay, you tell them, in something that they understand, right? Okay, so let's see. The next thing I wanted to do is something kind of backwards. I've given you the radius is 15.5 centimeters, and then I've given that theta is 3 pi over 5. First question I want to ask you, is this in radians or is that degrees? And how do you know? Yeah, that's radians. How do you know? Because there's not a degree symbol. If I give you something like theta equals 2, that's in radians. The only time it's going to be in degrees is if there's a degree symbol on it, because radians is the real number measure, see? Okay? Well, what we're going to do is we're going to end up finding r on this. So the question on the, or not r, I'm sorry, we're going to find s on this. So we just do s equals r times theta, right? The radius is 15.5 centimeters. We're already in radians, so we don't have to convert it like we did the last problem. And then just do this on the calculator. You don't need to reduce or anything. Just put it in the calculator. So 15.5, and then times pi, and then divide by 5. And then we'll round that off to, say, 1 decimal. Okay, so that would give you approximately the length of that arc. So it would be approximately 9.7, and that would be in centimeters. All right, so that's the answer. Okay, so S equals r theta is the formula you use, the connection between the radius, the central angle, and the subtended arc. Okay, so let's go to the next page. I'll probably have you do one problem, or these two problems. Let's do these two problems, and let's see if you can figure these two out. I'm asking this one a little bit different. This one I'm asking for you to find theta if I give you r and s. You use the same formula, but you're going to have to solve an equation to do so. Okay, so let's go ahead and pause, and then resume when you're ready to check. Okay, so go ahead and let's check what you did and see if you did this on the right track, and I'll kind of talk through this. The idea is you have the radius was 12.2 meters, and the central angle is 120. So the first thing you had to do is convert this to radians. If you didn't do that, you would have got an answer that wouldn't have made any sense. It would have been way too big. So 120 times pi over 180, reduce the fraction to 2 pi over 3. You don't even have to do that because you're going to use your calculator anyway. And then S equals r theta, take the radius times theta, and this is what I got. And I think I put it in my calculator like this, 12.2 times 2 pi divided by 3. Then I reduce the fraction. Okay, so the next one, we just have S as r theta. You may have done this slightly different than I did. you could have just plugged in at the beginning, but since I'm finding theta, I divided both sides of my formula by r, and by doing that, I just rearrange it so I have this formula. Then I just did s, which I gave you, r, which I gave you, divided on the calculator, and boom, I'm done. Okay, that's it. That's the way I'd do that. All right. Okay, let's go to the last thing, is that what we call the area of a sector. And want to go through this. So the idea is a sector of a circle is just a little piece of it. Again, you have a central angle that you would call theta. You would have the radius. That would be the subtended arc. So it's kind of like a slice of pizza on this. I like this pizza dude. So pizza guy, just think of it like that as a sector. And to derive a formula for this, we're going to do a proportion again. And a part to whole. Okay, the part would be just this sector. The whole would be the whole entire circle. So we're going to compare the area of the sector to the area of the whole circle. And then we're going to compare this arc length, S, that's a part, to the whole distance around the circle, which is the circumference. Okay, so there's a couple of things you got to know. You got to know the area of a circle is this formula. Pi r squared. All right, and then circumference of a circle is c is equal to 2 pi r. All right, my dad told me a joke one I can't remember how it goes. Whenever I hear pi r squared, the punchline of that joke was cornbread are round, pi r square, or something like. No, I don't know. It had something to do with that. But every time I think of this, I think of that joke. Okay, cornbread are round. Now, pi r, never mind. You could probably Google it and find that joke on the internet somewhere. Okay, so anyway, what we're going to do is we're going to set this up. So area of a sector is going to be A. That's what we're trying to find. Area of a circle is pi r squared. That's equal to arc length of sector. Well, the arc length of the sector is S. But S is equal to r theta. Okay, so we have that. So what I'm going to do on this is instead of putting S there, I'm going to put r theta. The circumference of a circle is 2 pi r. Okay, so see, notice we have area, we have r and theta as our only two variables. One thing that I see happens on this is that will cancel out. So you would just end up with A over pi r squared is equal to theta over 2 pi. All right, now I'm going to do this problem a little bit different. I'm not going to cross multiply on this. I'm just going to get rid of this denominator. If I want to get rid of that denominator, all I got to do in this equation is multiply both sides by pi r squared. Okay, it goes like that. All right, so we have A equals, and then notice on this the pi's cross out. So we're left with theta r squared over 2. Okay, so if you take theta in radians times the square of the radius over 2, you're going to get that. Okay, now a lot of times we write this like this. You'll see it in a textbook written as theta r squared, or sometimes they'll change the order. I don't know how our textbook does that, but it doesn't really matter what order you have that in. So I'm just going to write it the way I see it most of the time, is 1/2 r squared theta. And then again, theta's got to be in radians, all right? It's good at this level to start, I want you to get an appreciation for how mathematicians figure this stuff out. So that's the derivation, and that's how we came up with that formula. Okay, just some logic and a simple proportion. Okay, let's go next page, and last page on your handout. Hey. We're going to do the area of a sector. Okay, so on this particular example, the sector is what's highlighted in the light blue, have a 100-degree central angle, and the radius is 12. So I'm just going to write down the radius is 12 centimeters, the central angle is 100 degrees. Now, what do you have to do with 100 degrees? Yeah, you got to change that to radians. So we multiply by pi over 180. Now on this, you can go ahead and reduce the fraction if you want to. And again, I'm just going to kind of do this like this. Students need to really practice reducing fractions. I find that to be problematic for some students. So you can cross out the zeros at the end. That's the only time you can do that. Sometimes I'll see students aren't paying attention. I have had students before do this. That's 18 over 19. No, it isn't. Okay, that's totally wrong. Okay, I'm not making fun of anybody. I'm just saying, you know, it works in this case because you're dividing by 10. So what you'd end up having is you would have 10 pi over 18, and then you can reduce that down by 2. So you would end up getting 5 pi over 9 radians is what you have then. Okay, so the formula is area equals 1/2 r squared theta. So I'm just going to plug everything in. Now you can use 0.5. Since you're going to do this on the calculator, you can just use 0.5 for 1/2. The radius is 12 centimeters. So we're going to do that. I'm going to leave the units in here because I want to show you something. And then the radian measure is 5 pi over 9. And you can change 5 pi over 9 to a decimal if you want to. Now, when you have these really cool graphing calculators, they can kind of do a lot of this stuff in one step. Just type it in exactly this way, 0.5 parentheses, and you don't have to have parentheses on that, but you can bypass that. So I have that, and then parentheses 5 pi over 9, and then just let the calculator do all the calculation for you, and that'll give you the answer to the problem. Okay, so that's going to be 125. I'll round that off to 1 decimal, so the 6 is going to round up to 7. And notice you have a centimeter squared. Okay, and you want to know that the units on area are square units, square centimeters, square feet, and so forth. That's why. Okay, because anytime you have an area formula, there's going to be something in there that's being squared. So that's the idea. Okay, now let's take a look at this one. This one is just kind of asking it backwards. So we have the area of a circle is this. So I'm going to write down area. When I do these problems, I like to write down what my variables are. So I get that. The central angle, theta, is 1.2 radians. Okay, so we don't have to worry about doing a conversion. We're already in radians. Okay, then I would write down the formula. Area equals 1/2 r squared theta. Now what we're going to do is we're going to find r. All right, now you can do this a couple of different ways on this. You could go through and just plug in now. I think I'm going to go ahead and just do it that way. It's just kind of plug in. Or actually, let's write this like this because I think you might do it a little bit better. 1/2, let's change that to 0.5 r squared theta. Now, if we want to find we're finding r, let's just plug everything in. So the area is 20.5 inches squared. I'm going to have you put the units in because I want to show you what happens. Then we have 0.5. We're finding the r, so we just leave that alone. Okay, like that. And then what we have is we have theta. Theta was given as 1.2 radians. Now, radians is not technically a unit. It's more like a placeholder, so I'm going to leave that out. So now I'm going to solve this equation. So what I'd have to do is, I could do this, and you can skip a few steps on this. I'm just going to bring that down and write that like this. Then I'm going to do 1.2 times 0.5. And that's going to give me 0.6 r to the second. Okay, let's move over here and finish this up. Okay, so we got this, 0.6 r to the second. Okay, to solve this equation, you got to divide by 0.6. Okay, that'll get r squared by itself. Now I'm going to take my calculator, 20.5 divided by 0.6. And it's got a bunch of decimals. Now what I like to do is just kind of put this in, see how the 6's repeat. That thing does not go to 7. That's going to be 6's forever. The calculator's just rounding up. So what this really is it's repeating 6's. So I got that. Okay, now here's what I'm going to do. Now, from your background, what do you do to both sides of this equation to make the r squared become r? Yeah, you do the square root of both sides. So the square root of something squared undoes the operation, just giving you r. Now I'm going to do the square root on this. So if I just go, and watch how I do this. I do this a lot. You have this ANS key that stores the last calculation in your memory. So you can go second x squared to get the square root symbol to come out. So instead of retyping that, you can go second negative, just get ANS, and that automatically plugs that in. Saves you a little bit of time, maybe a couple of seconds, but hey, in the modern world, seconds are valuable. The other thing I wanted to show you is when you do the square root of inches squared, that just becomes inches. So you would have 5.8 inches, and that's what we would expect for the radius, is that to just be a unit in inches, not square inches. Okay. All right, so I'll let you finish up these last two problems, and then that'll wrap up this second part. 7.1 is a very long section. I have to do it in 3 parts and kind of break it up into those pieces. So let's go ahead and go here. Go ahead and pause the recording, and then we'll check our results. Okay, so here's the results I got. On the first one, I got 13.1 square centimeters. Second one, I got 33.6 centimeters. I could see how you could be a little off on number 2. It depends on how many decimals you use. I usually recommend students just use whatever decimals come out on the calculator when you're calculating and round at the very end. That's the best way. I'll kind of talk through this, and then that'll wrap that up for us. So we have 1/2 r squared theta. This is already in radians. So this one we just do half is 0.5. The radius is 5 squared. Pi over 3. Put that in your calculator. If you put it in correctly, that's what you have. Okay, this one, there's more than one way to do this, but you have to use the formula. I went ahead and just plugged in. I started by changing the 35 to radians. If you didn't do that, you would not have got a reasonable answer. You would have got a radius that wouldn't have made any sense. And so I went ahead and just reduced that. Now you can change this when you do 35 pi over 180. You get this on your calculator, right? And then you can use that if you want to. So what I did is I plugged in 345, 0.5 r squared, and I did this. And what I did is I just took 0.5 times 7 pi over 36 and got the 0.30543269191. Now see, if I rounded that to 0.3, I would have some significant error in my calculation. It wouldn't be that accurate. So I went ahead and just left that in. Then I divided both sides by that to get r squared by itself, took square root of both sides, and then rounded the answer at the end. So that's the idea. Okay, so that will wrap that up. There's a lot of information in this part of the section. What you're doing is not that big of a deal. Shouldn't be that hard for you, I don't think. So just remember this. Pi radians is 180, and 2 pi radians is twice that, so it's 360. That's kind of, if you remember that, you can remember how to do a lot of stuff in this section. All right, so I hope that helped you out. Good luck on your homework. Let me know if you need any help with anything.